AI news I found interesting. Starting Friday 14th, Claude Code will default to the auto mode classifier, meaning each action the model wants to take is first sent to a smaller classifier model to decide if it's safe or not to run. Anthropic did an internal controlled study that found humans only caught 13% of dangerous commands, while auto mode blocked 89%. They also noticed that humans started at 17%, but as the session dragged on, that number fell to just 5%. Confirming these findings is also a small browser game created by Alex Wouters, which simulated the Claude Code environment where players had to approve commands. Over 40,000 players played, and on average, they missed 1 out of 3 threats. So, approval fatigue is real. And even though auto mode is not perfect, it only really needs to be better than the average human for it to be the default. On other news, Meta released Muse Glimmer, a 30 billion parameter model under an Apache license. Its 4-bit quantized version can run on 20 gigs of VRAM, so a lot of MacBooks can run it locally. It's an impressive model for its size, especially in agentic work, and it's also a step in the right direction for open-weight models we can actually run locally. At the same time, Zuckerberg released a 6,500-word essay titled "The Future is for Everyone," arguing for American open source AI and taking direct aim at OpenAI and Anthropic for using safety to justify locking models down. Meta also released Muse Spark 1.2 last week. It's not the smartest model, but I am bringing it up because it's fast, averaging 125 tokens per second, and if you live in the US, you can access the contributor pricing for less than DeepSeek v4 Flash. This will be even more enticing if DeepSeek goes through with their announced price hikes. One important caveat is that for this price, you are allowing Meta to train on your data. So it only really makes sense for side projects or work on open source with no real client data. And finally, on the cybersecurity side, Corma reported what they call the defensive gap. They ran frontier models on realistic enterprise environments as both attackers and defenders. The attackers had to plan to backdoor, and the defenders had to find and defend against it. In their tests, the attackers succeeded 85% of the time, while defenders only detected 19% of the attacks. Now, that's a problem, since defenders failed to find backdoors 78% of the time, even when the defender was an identical copy of the same model that planted it. But Corma is selling the exact product that this study justifies, so take their findings with a grain of salt. That's it for today. If you think this is useful, drop a comment below.